Hello, my name is Dan Brunner, and in this video, I'll be going over how to solve problem 10.005 from Chapter 10 in the Fundamentals of Mass and Heat Transfer textbook. So looking at the problem statement, we have a long 2 mm diameter wire. This wire is dissipating 4,700 watts per meter worth of power, and it reaches a surface temperature of 118 degrees Celsius when submerged in water at 1 atmosphere. So we're trying to find the heat transfer coefficient, and we're also trying to estimate the value of the correlation coefficient, C subscript SF. So we're given this information. The diameter of the wire is 2 mm. The heat transfer rate per unit length is 4.7 kilowatts per meter. The surface temperature is 391 Kelvin. The pressure of the water is 1 atmosphere. And then here are all of the properties of water at that temperature and pressure from the appendix in the textbook. Again, we're trying to find the heat transfer coefficient and the correlation coefficient. So to help us solve this problem, we'll be assuming that um, the system has reached steady state. The wire and the surrounding fluid have constant properties. The water has a uniform temperature, and there's negligible net radiation. To solve the problem, we'll also be looking at these two main governing equations. First, we have Newton's law of cooling per unit length, of course, and we'll be rearranging this equation to solve for the coefficient h here, which is asked for in the first part of the problem. And then we also have this equation for the correlation coefficient using all of the properties that I had just shown. And we can also incorporate the heat flux, which we can use the first equation here, Newton's law of cooling, for as well. So to go about and solve this, I first rearranged Newton's law of cooling. We were given the heat the heat transfer rate per unit length. And so we have all of the unknowns we need to solve for the heat transfer coefficient H. And so when I plug in all those values, I'm getting 41.9 kilowatts per square meter Kelvin. If I rearrange this heat flux uh, and write it as the heat transfer rate per unit length divided by the um, circumference of the wire, pi d, I get this equation right here. And I can rearrange and solve for the correlation coefficient, which is found in the denominator of this function right here. And so when I rearrange all that, this is the equation that I get. This row is supposed to be a Q. That's my mistake. And when you go ahead and substitute in all of the values that are given, and you bring this pi d over to the other side, you get that the correlation coefficient is about 0.013. The true solution for the problem lists it as 0.014. And the reason why there's this discrepancy is simply because instead of using 373.15 Kelvin, they use 373. And believe it or not, that little decimal makes makes this slight difference between the answer that I got and the answer that is provided in the solution. However, this is the correct approach and ultimately the correct answer as well. And so that is how you solve problem 10.005. Thank you.